This meeting is being recorded.
We're asked in question 28 from chapter 3 to compare the structures and identify the stronger base in each pair here. So then we're also asked to explain our choice. So first we're going to follow some steps here to determine the stronger base in each of these pairs. So first we're going to draw, or at least imagine the conjugate acid, and then we'll determine from the conjugate acid which is the stronger acid, which will be less stable. Then, once we determine the weaker acid, the more stable compound, that will be produced by the stronger base. So let's take a look at A here. And if we were to protonate this structure here versus protonation of the structure here, we would compare the stability of these conjugate acids, and the second acid is more stable, the weaker acid, this one here. Because the positive charge is better stabilized, that would result on nitrogen versus a positive charge that would result on oxygen. So if we determine this over here, this compound to be the stronger acid, the less stable compound, we would know that this here would be our stronger base. So let's take a look at B here. And the first base, if we were to take a look here, would have a lone pair that is delocalized due to resonance. So we could draw multiple resonance structures here. Right? The second compound does not have a delocalized lone pair. It's localized. And this one was delocalized. So that can help us make a determination as far as the stronger or weaker base. So the first base would be a weaker base because the lone pair is less available since it's delocalized is to function as a base. So this would be our stronger base, the compound with the localized lone pair on the nitrogen. So let's take a look at C here. And in the first structure, we have a lone pair on nitrogen that is able to be resonance stabilized. So this is a delocalized lone pair. And then over here, this nitrogen has a localized lone pair. So once again, the first compound will be the weaker base because the lone pair is less available due to being delocalized. And then this will be our stronger base with the localized lone pair. So in the last example here, if we were to protonate these compounds, again, we would have a positive charge on our oxygen. The second compound, if that was protonated, we would get a positive charge on nitrogen. And we could conclude that the second base would be our stronger base because we would produce the weaker conjugate acid because the nitrogen, again, is more stable, able to stabilize that positive charge better than oxygen.